welcome to the Voice of Ethernet. The story of Ethernet is best told in personal stories shared by its own creators, providers, and users from the perspective that they had. The Voice of Ethernet archive is dedicated to preserving Ethernet's oral history, recording pivotal events that may have been forgotten or remain unknown, through a collection of spoken records and interviews with individuals engaged in the technology global emergence as the foundation of the internet. Today we'll talk with Bob Groh, one of the people behind Ethernet stories, his account and experience with an important milestone in the technology's history. So Bob, thanks for joining us. Can you, in a short fashion, introduce yourself?
Thank you. I've been in the local area network area technology for quite a while. Started at about 1976, I think, was when I worked on my first LAN design. And then began participating in IEEE 802 standards activities in 1981. I'm a latecomer to Ethernet, though, as I was involved in other parts in 802, but did start doing Ethernet standards with gigabit Ethernet in about 96. So it's been interesting to watch the evolution of the technology and to see the factors that drive it. But along the way, I've had an opportunity to chair the 802.3 Ethernet working group for a few years and have some other volunteer positions in standards.
So just as a context, even though I've got grey hair, I think you started in standards when I went into university.
Yes, and it's now at the point where you're participating with people, and you know, I've been involved a lot longer than they have been alive.
I have the same feeling. So if we go back to the start, what was the driver? What prompted you to get involved with this technology?
Well, I got involved even during university years in looking at some of the more advanced and more futuristic looks at technology and things that would be happening. For example, getting to know Alan Kay very briefly a little bit, who was at Xerox PARC, but he was driving some of the application space, and Smalltalk was one of the things that he was on. But you still got an exposure to what the industry thought might be happening in future years with networking and computer technologies and applications that went on those computers. And that sort of drove me to, I had the opportunity to join an advanced development group that was looking at integrated voice and data applications for communications, basically being able to communicate with whatever medium you want to, anytime you want to, from wherever you want to, was the objective. In the 70s, the technology wasn't there, though. So
I was going to say this was starting from Ethernet as a tool to fix a bunch of problems, and it sounds like you were way ahead of the game with those problems. But you probably were sketching out. You ended up with some idea of what was required to solve them.
Yeah, to do it economically so that it could have an application really wasn't possible at the time. But to look at how things might evolve, there are multiple groups throughout the industry doing similar sorts of things. Different names. The paperless office was one of the things that they described, and we still have
didn't work out so well, did it?
Yeah,
actually thinking about this, the pandemic is probably the greatest contribution to the paperless office because people don't have printers hanging around.
Yeah, well, but that was one of the concepts. I don't think it was Xerox's objective to get rid of paper, but they did want at Xerox PARC to enhance communications and the ability to use technology for people's needs. And that was certainly one of the early drivers of Ethernet.
They didn't want the ability to share those very expensive laser printers between multiple people.
As you may be aware, one of the other former chairs of 802.3 was the person that built the controller that put the first laser printer onto the experimental Ethernet.
Which chair
That's
is
Jeff
that?
Thompson.
So we are going to be talking to Jeff later in the series.
Yes. So there are a number of people that have roots going back to those early days that have contributed to the progress of Ethernet.
How would you describe, your contributions into the technology evolution?
Well, as I mentioned, that early project that I was on was focused fairly heavily on voice, including telephony, as well as voice messages, things of that sort. And so we investigated available network technologies. And at that time, Ethernet did not seem like the right fit.
What did look like the right fit?
So I went off and invented something that had levels of qualities of service designed into the protocol. That protocol actually eventually became the base protocol in 802.4 and also for FDDI. But its driving force was to handle telephony voice with the delays and all of that are expected. And at the same time, you did see people in the Ethernet community saying, let's put voice on Ethernet now. And this was with the big old fat yellow cable.
I have to get hold of a piece of that so I can wave it around when people talk to me about it.
Yeah. So that had me dealing with alternate ways of trying to get the qualities of service. And that was, frankly, something that people had not seen early on with Ethernet, was the quality of service capabilities that some people wanted for some of these advanced systems. But as things have evolved in the industry, the quality of service has been delivered for Ethernet. And it certainly is a viable candidate today, as we all know, for carrying IP telephony just fine. So we just didn't know how to do it back in 1980.
So this is really, that really came from a different place than the original sort of goals of ARPANET and the original internet.
Yes, it was. The exchange of files and data, of course, was a driver of the original ARPANET, being able to get physicists to exchange their files. And one of the things in my early working on these multimedia communications was observing the traffic statistics on the ARPANET, and that email was the dominant traffic, which proves that people being able to communicate is a very important ingredient. Not just write something down, put it in a file, and someone being able to get to that file, but the more interactive types of communications, and email is rarely real time, but it still is an important communication tool that's vital even today.
Yes, I do remember in the early days, at least in Australia, you had to be at a university to get on the internet and to get an email account.
With Ethernet, what you had is a community of a very broad community. You might even refer to it as the ecosystem of providers and manufacturers of equipment, those that were looking at applications as well, that all chose to cooperate to build a successful technology.
I'm just thinking it must have been really interesting in those businesses to go out and try and ask for money on this technology where the business didn't exist yet, and it sounded futuristic to say the least.
Yes, I was with Burles Corporation in the early days. Anybody that's old enough to remember that corporation and its old incarnation. But I remember the VP of engineering of Burles sitting down with us, and I don't know how we're going to sell this stuff.
So we may not have had this conversation, but one of the things I did early in my career was I wrote a terminal emulator for a Burroughs TD830 that you could use the V100 to talk to it. And I believe I also worked on Pulse Select as well. So I remember some of that stuff.
Yeah. And when you were working on this stuff early in the, in the late 70s, early 80s, you wanted flat panel displays, and people were talking about them. They weren't very real. So you're still doing the old green CRT to write your email.
Yeah.
And that was the state of communications. But you had the basis on which the richness of communications that we have now was built and has been able to evolve.
So you mentioned earlier that you've done some work in .4, which was token bus, and also I think you were probably involved in .5, which was token ring. And
Yeah,
so without trying to open old scars, right? Why do you think Ethernet .3 succeeded when those other technologies faded away?
well, yeah, 1981 was about the time we finally got the dots, as some people refer to it. Originally, it was one project, Project 802, and one of the important compromises was let's let the very strong and powerful in terms of corporate interest, even though it was an individual process, there's still corporate interest driving the participation. That the interest was fairly well divided between those people that were in the manufacturing space, which is what became the token bus 802.4, IBM heavily driving the 802.5 token ring. And in 802.3, instead of coming from an existing alliance of manufacturers in 802.4, you had three companies that provided different perspectives that came up with the Ethernet Blue Book. That was Digital Equipment Corporation, Intel Corporation, and Xerox Corporation.
Otherwise known as DICS.
Yep. Computers, basically the vision and the IP from Xerox and Intel providing the realities of what can be done in semiconductors at the time. And so that's original draft of the Ethernet specification, which was of course based upon the experimental Ethernet developed at Xerox PARC, but that early specification then drew broad industry support. And it's that rich breadth of companies that was very critical to the success. And you didn't see that level of broad commitment in 802.4. And 802.5, it seemed to be that there was more interest in holding the technology a little closer by the people that were driving that standard. The openness, very low intellectual property barriers to do Ethernet made it easy to join that infrastructure of providers, and that's what led to Ethernet being successful early on, and ultimately supplanting all of the alternative wired technologies for communication in the local area.
So I think where you get down to is that one or another Ethernet created the culture of success.
It certainly did that. It gave an opportunity to participate and in a meaningful way to be able to develop product and to leverage off of the work of other companies and do it in a cooperative way that was somewhat lacking from the other 802 local network technologies.
Got it. We will actually we're going to have a talk to Gary Robinson, who tells a story about that as well.
Yeah, Gary was an important player in being able to get things to progress from the argument about which 802 dot, or to create the
right answer. Yeah, who has the right answer? So can you talk to us a little bit about hurdles the Ethernet faced in the early days?
Well, we mentioned one of the things that is still interesting is when I'll run into someone traveling. I remember riding a shuttle bus to the rental car lot. Someone asked me what I do, and I say Ethernet. Oh yeah, I used to work with that big fat yellow cable. And I think that big fat yellow cable was one of the hurdles that had to be overcome. Do
you think it was better or worse than CheaperNet?
It was better than CheaperNet, mostly because CheaperNet, or the coax, smaller coax, but connectorized to your device, it was too easy for people to break the bus.
I actually did that quite a lot when I was working with a company that was our network. So I could add a new segment into my desk and break the guy on the other side of the network.
Yeah. So those two early generations of standard Ethernet, 802.3, did have limitations. When people recognized the way that buildings are constructed and where there are wiring closets and where there are pathways to take your cabling and that sort of thing, and they made that adjustment with 10 base T to be able to utilize the building infrastructure for businesses and have a cabling topology that matched that well. That was one of the very important evolutions of Ethernet that led to its success.
So we should all say a profound thank you for the for AT&T and then its changes from being a monopoly, which made all that that cable plant available.
Well, or you could thank Carter with the Carter phone decision, wherever it comes from. The courts, of course, did open up the way for competition in the space. And yes, to be able to share the wiring closet for phone with other technologies was an important ability to certainly to being able to build 10 base T networks that serviced an enterprise.
And then became the standard for how we build the bulk of Ethernet deployed today. Is like it goes this way because that's how buildings are built and everyone knows how it works, and so it becomes easy to build and adopt.
Yeah, certainly for the people that are using the, keying information into their personal computer or whatever it might be. That is the topology that you need to have to get to their desk. The data center today, though,
very different.
We adapt the cabling topologies, the reaches, all of that to meet the needs of the way data centers are built, configured, and we develop the right technologies in the standard to allow the providers of equipment to deliver high bandwidth to the data center.
Yes, you'll have to forgive my small amount of bias coming from the enterprise side of the house. That's what I tend to think about.
Uh-huh.
So my next thought was about what made Ethernet succeed, and I think you've sort of covered it already, which is adapting to infrastructure and then being mindful of what use cases needed, because we have everything from traditional base T to the short reach cabling in the data center to the long reach. And so we've adapted to all those different use cases. And I think that again is probably partly a cultural thing to recognize there isn't one answer.
Yeah, I would probably add a third ingredient to that, which is the Ethernet community has gone out of their way to avoid the not invented here problem.
What do you mean?
Well, take gigabit Ethernet. Well, let's start with fast Ethernet, 100 megabit. They decided we don't need to go off and do all of the standardization of PHYs, the fiber optic or the twisted pair. They did that over in ANSI with FDDI. So let's just take the FDDI TP-PMD specification, and let's take the fiber optic specs, the PMD of FDDI, and we'll just run Ethernet over those. So you already had a number of the choices made to be able to deliver the 100 megabits, shorter time to market, proven technology, nobody having to latch on to a particular technology hoping they'd have some intellectual property advantages, but it keeps a level playing field for all of those in the infrastructure wanting to build product.
So in my head, if you're into sports, this is a play position type thing, right? This is know what your job is and do that job really well. Don't try and do everyone else's job.
Well, yes, that's certainly an important part of it.
All right, so I've got this very simple question, which is really to expound. What do you think is the underlying effect of Ethernet in the world? I mean, when I think about it, Ethernet enabled the internet, and so the effect has been enormous. I don't actually know how you would quantify it.
Agreed. It's very difficult to quantify, and it's difficult to separate from the other technological innovations that used Ethernet. Which one, just having the bandwidth is not necessarily the driver, but having the bandwidth to communicate allows the developers of personal computers and the applications that run on personal computers to do things. And so there's a synergy between the different technology interests, not just the local area network part of things, that drives the fast progress. And it's that synergy of virtually any kind of device you want to connect could be connected with Ethernet, and you could make it successful starting with the connection to the internet, basically being able to extend that reach out of the local area to anywhere in the world.
So maybe again, this sort of goes back to doing the things you're supposed to do, and the benefit of conceptually adopting like the ISO 7-layer framework and knowing which bit you're doing, so you don't produce an entirely closed system which says you need to use this file with this network layer, with this, with this, with this. The fact that you could mix and match meant the people building the bottom layers didn't have to bet on who was going to win at the top.
Yes, and you let them compete in their space. You have an infrastructure where people can compete with developing the best Ethernet chipset or whatever it might be. When switching got added, which was another important contributor to the evolution of Ethernet. But if you build the switches, bridging was already defined and was recognized as something that would happen in the very early days of 802. But it didn't really develop for a number of years afterwards. And then as it became more and more popular, that was an important ingredient. And you could allow competition with who could build the best switch to connect the Ethernets together. And we didn't have to worry about that within 802.3, and certainly not within 802. You just wanted to have the rules so that Ethernets that were bridged or switched together would convey the traffic reliably.
Okay, so if we move on a little bit, what areas of Ethernet development today are, most interesting? What are you watching? What are you enjoying?
Well, I've sort of hooked up with some automotive folks. I'm engaged in running a project right now for optical networking inside the automobile or the vehicle, and
that's the plastic optical fiber, right?
Well, that's what we did at the gigabit. We'll probably use glass fiber. It may be the most appropriate, but that's one of the debates that's going on in 2021 is what's the medium going to be? And is it going to, the main thing is to provide the bandwidth. And who would have dreamed that you'd need 50 gigabits per second inside an automobile?
If you think about it, if you look at the picture of the cars I've seen, I think from BMW, it's basically a small enterprise driving around, including its data center in the middle.
Yeah, the electronic control units, which are the computers, the servers, if you will, they're connected on a backbone and they're going to want to exchange files. And there are corollaries to data center needs rolling on wheels.
And if you think about all the stuff for automatic driving, that's a huge amount of sensor and machine vision stuff that's got to go live. That's got to happen live.
Yeah, one of the challenges in the automotive space is you have such a broad range of bandwidth requirements. Some of the sensors don't really produce a lot of data.
Well,
cameras, as you go to, oh, sorry, go ahead.
I'm involved in some of the 10 megabit stuff, and so it's always interesting to see the dynamic range that's required these days.
Yeah, LiDAR is going to produce data, but not at the same rate that a high-res video camera, uncompressed, will produce data.
I think people forget that video cameras these days are actually becoming frame grabbers.
Well, And then you need a lot of horsepower in the, I shouldn't use horsepower in the automotive context, I guess. You need a lot of compute power in those electronic control units to process and do all of the digital signal processing, recognition of hazards, everything else that you get from that raw camera feed. To be able to guess that someone is going to step off the curb is a lot different than just taking a picture of someone standing on the curb.
I don't think we want them to guess exactly. That would probably be bad thing.
Yeah, and well, you have to recognize a potential hazard before you know that it is a real hazard, and that's where I guess I would use the word guess.
I'm not sure the safety evaluations would use that particular term.
As I said at one time, I don't always choose the most politically correct words, but you are trying to predict what is going to happen in very unpredictable situations.
Yeah, and it's a difficult problem to solve.
When another vehicle is going to change lanes and cut over in front of you and give you an unsafe following distance, or cut over not having seen you in their blind spot, is even a more imminent thing that you have to be able to recognize the possible hazards.
I think if we summarize this, going for an all Ethernet car produces a bunch of interesting problems in terms of processing, also in terms of safety and regulation.
Yes, and as many would know that in the last number of years, there have typically been separate networks within the vehicle. You know, one for the infotainment to show the videos and run to the screen in the back seat so your kids can watch a movie, or that sort of thing, compared to the network that's tying together the powertrain of the vehicle, and then monitoring the chassis and other things that are actually part of the automobile as opposed to the passenger experience within the automobile. Very different applications, and they had been servicing those with multiple networks, but the realization has come that cabling inside the vehicle is weight. Weight is lower gas mileage or lower fuel economy. So consequently, one network.
Maybe that's another thing which, over the history, Ethernet has become the platform on which we converge networks.
Mm-hmm. And it's open. I think the automotive people have seen the opportunity of using proven technology and just adapting it to the specific needs of their market.
Okay, so as a shameless plug for ourselves, what do you think about the idea of doing like an archive of oral history?
It's rather interesting. For some, maybe it's just because I'm getting old, but I reflect upon those people that have been early contributors and have helped lead and drive parts of the communications revolution, really. And a lot of them are ready to leave us. You know, in terms of age, they're well along. And so to capture the history of those people that played such an important role in the evolution of communication is a very worthwhile thing to do. So you can get the words from those that were there.
I'll pat myself on the head. So any final thoughts you'd like to leave us with?
Well, it's been a wonderful career for me to work in the local network field, and the people that I have been able to work with, mostly a joy to work with. Occasionally you have your frustrations and conflicts, but people of incredible capability that come together to build such an important and worthwhile technology is is really good. You need somebody that understands all the problems of transmission lines and, you know, echo cancellation and crosstalk and all of that. And yet you also need somebody that knows how to manage a system. And all of those ingredients, all of those skill sets show up in the development of Ethernet standards and Ethernet technology.
That's an excellent closing. Right, so thank you, Mr. Grow. I really appreciate your time. So, you know, we appreciate the stories from Bob Grow, and I'm sure that a lot of people I know will be wanting to go listen to this. Please tune in to hear other Voice of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore what the technologies story might go next. Thank you for joining.